We present MobiSweep, an approach to explore quick, three-dimensional shape composition during early phase spatial design ideation. MobiSweep is inspired by the observation that sweep surfaces inherently lend themselves to the intuitive physical action of sweeping a planar section along a trajectory in 3D space. The interactions behind MobiSweep utilize this spatial relationship between the physical action of sweeping and the resulting creation of a swept surface. We introduce an interaction metaphor that maps a handheld smartphone to a spatial reference plane in the 3D virtual space. This metaphor naturally lends itself to spatial actions for creating, modifying, and manipulating shapes through direct physical action from the user. The orientation of the phone is directly mapped to that of the reference plane. Thus, simply rotating the phone results in the rotation of the reference plane. For translating the plane, MobiSweep utilizes multi-touch gestures. The use of a two-finger panning gesture allows for in-plane translations. Additionally, users can also define planar curves in 3D space by sketching on the smartphone screen. We introduce one- and three-finger gestures for allowing users to translate the plane along its normal direction. While the one-finger press and hold gesture allows for quick and coarse movements, the three-finger pinch spread gesture enables users to precisely position the plane. The simultaneous use of orientation and offsetting emulates the action of sweeping the plane along a 3D trajectory. Thus, by simply substituting the reference plane with a planar curve, users can emulate the action of sweeping a handheld cross-section. Users can immediately bend the swept surface by directly reorienting the phone. Using two-finger gestures, users can pan and scale the cross-section of the swept surface. Users can also directly redefine the cross-sectional shape by simply sketching the section on the smartphone. Finally, by attaching the reference plane to an existing shape, users can rotate, translate, scale, copy, delete, and color the attached shape through the same combinations of direct orientation control and multi-touch gestures. These context-aware interactions allow for quick externalization of design concepts in the form of three-dimensional compositions. We evaluated our approach with 14 participants, including students from mechanical engineering and other disciplines. Followed by a 20-minute practice session with MobiSweep, users were asked to generate design concepts of products such as lamps, kettles, and jars. We observed that the users could associate with the sweeping action during the shape creation. Interestingly, the lack of explicit 3D position tracking helped the users rest their arms without worrying about accidental interactions with our system. Users' feedback strongly supported our premise that it is both possible and useful to effectively externalize spatial design concepts by embedding constrained bodily actions within the shape creation process itself. Further, the simple setup involving only a smartphone and a laptop computer was perceived to be of high value by users towards collaborative ideation scenarios. At its core, MobiSweep allowed us to explore an embodied approach towards direct spatial ideation by introducing a new design space of constrained mobile interactions. Thanks for watching.